Section 5.4 deals with medians and altitudes, so more vocabulary identifying certain lines within a triangle. A median of a triangle is a segment whose endpoints start at a vertex and goes to the midpoint of the opposite side. So you'll identify the midpoint when you see these tick marks to show that this is the halfway point of the opposite side. The first theorem is talking about the concurrency of medians theorem. Remember, the concurrency means the point where all of the medians are going to intersect. So you can use this formula to find certain lengths within a median. So for example, if I have this point of concurrency, I know that this length is 2/3 of the entire length. So what you can do is you can cut it, like if they give you the big one, you can cut it in half and then you know what the small length has to be. You can either then decide if you need to answer the small length or answer the total length. Another terminology before we get started finding those lengths is what the actual point of concurrency of the medians is called, and that's a centroid. So you want to make sure that you've highlighted or starred or something the median, because you need to know that, and you'll need to know what a centroid is. Now, for any triangle, the centroid will always be inside the triangle. And for those of you that might be doing some classes with engineering, the centroid is the center of gravity of a triangle, because that's where the point where you can balance for the triangular shape. So let's look at an example here where we're trying to find some certain lengths. So we have in this diagram that x to a is 8. And they want me to find x to b, which is the entire length. So remember, if I'm giving you the long piece, I should be able to find the short piece because I'm just going to do half of this. This length is double of this. So if this is 8, that means my short length has to be 4. Now I'm just going to pay attention to what they're wanting me to find. They want me to find xb, so therefore I'm just going to add my total, which should be 12. I want you to pause the video and try the got it question on letter A. On letter A, they give you that from Z to A is 9. So again, they gave you the long leg, so I would have to cut it in half to find the short leg. If I was going the other direction, if they gave me the short leg, then I would just double it to go the other way. But since they gave me the long leg, I'm going to cut it in half, which means half of 9 is going to be 4.5. And then I'm going to ask what they want me to find. They want me to find ZC, so I'm going to add the two together and get 13.5. Now on letter B of the got it question, it's asking for the ratio of ZA to AC. Remember, we kind of already talked about it. We said that this has to be double of this, so my ratio is going to be 2 to 1 because the longer leg always has to be double of the smaller leg. Okay, let's continue on with altitudes. So an altitude is going to be a perpendicular line segment that goes from the vertex to the opposite side. And I'm going to know if it's perpendicular by it showing you that little box, that right angle box, and that's how I'm going to show if it's going to be an altitude. So again, I would highlight this or star it so you know that terminology. So these next questions is just practicing vocab. So in this triangle, it wants me to identify what PR is. Is it a median, an altitude, or neither? So when I look at PR, I see this right angle. So that tells me it's perpendicular. So that automatically tells me it has to be an altitude because it goes from the vertex to the opposite side and it's showing it's perpendicular. Now let's look at the next one. QT. QT goes here. So I see it goes from the vertex to the opposite side. Now I see these tick marks, which is indicating these two are congruent and this has to be the midpoint. So therefore it has to be a median because it goes from the vertex to the midpoint of the opposite side. I want you to pause the video and try the got it question. Within the got it question though, you do not have to explain since we kind of took care of that up here. So I just want you to identify which of those three it would be. Okay, so for the first one, you have AD. AD goes here. I see that it cuts it into two congruent pieces, so that means that this is a midpoint. So therefore A has to be a median. EG does not go from a vertex, so this is neither. We actually went through what EG was in section 5.1. It is actually called a midsegment. So this one is neither because it doesn't fit either of those vocabulary words. CF goes from the vertex to the opposite side. I see the right angle, so therefore it has to be an altitude. Okay, so now point of concurrency for the altitudes. The orthocenter is what the point of concurrency is called for altitudes. Okay, so we had centroid and now we have orthocenter. For an orthocenter, it can be inside, it can be on it, or it can be outside depending on what triangle it is. If it was a centroid, remember that's always inside of the triangle because it's that center balance point. So what we're going to do is we're going to actually have to find the orthocenter. So we're going to have to graph what our altitudes are so that we can find our orthocenter. So this question gives me vertices, so I'm going to go ahead and plot those points. And then what I'm going to have to do is to find the orthocenter. So knowing an orthocenter, that means I'm going to have to find altitudes. And then I'm going to have to know what an altitude is. So an altitude, remember, is the perpendicular line that goes from the vertex to the opposite side. So the first thing I'm going to do is I'm going to find a horizontal line if there's any, and I'm going to go to the opposite vertex and just draw my perpendicular line, right? So if I'm doing horizontal, my perpendicular line would be vertical, and vice versa. If it's a vertical line, my perpendicular line would be horizontal. So this one will be easy to find because all I have to do is go to the opposite vertex, draw my line straight down, and if you want to put in that right box, you can. Now, finding the other one takes a little bit more work. So since we already used AC, we now have to use one of the other two sides. So pick one of these two sides. I decided to use BC. Okay? You're going to count the rise and the run. You need to find the slope of BC. So I would start at the point, one of the points, count 1, 2, 3, 4. So I went down 4, and then I went right 1, 2, 3, 4. So my rise and my run is -4/4, which reduces to -1/1. The reason you need to find that slope is because in order for my altitude to be perpendicular, my slope has to be an opposite and reciprocal. So remember from chapter 3, we did slopes and we did parallel and perpendicular lines. So opposite and reciprocal means I'm going to change my slope. So opposite's going to make it become positive, reciprocal is going to flip it. But since it's 1 and 1, these numbers obviously aren't going to change, right? But reciprocal always means to flip it. So I have my slope, so now what I'm going to do is I'm going to start at the point opposite of the side that I was using. So that means I have to start at A, and I'm going to count my rise and my run. So I go up 1 over 1, up 1 over 1, and then I can draw in my altitude. So let's run through that one more time. Pick one of these two sides, find the slope. You need to change your slope so it becomes perpendicular, so you do the opposite and reciprocal. The part that people kind of struggle with is remembering that I need to go to the opposite vertex so that I can draw my altitude to connect to it. So then once I have those altitudes drawn, I just find their point of concurrency, which is their intersection, and write down their coordinates. So I went over 2 and up 4, so my answer is 2, 4. Alright, I want you to pause the video and see if you can do the next question. So on the next question, I went ahead and graphed it. Notice that this one is a right triangle. So if you remember from the previous, a right triangle will always have the orthocenter on the corner of where that right angle is. Because here's my horizontal line, so my perpendicular line would be this side DE, and vice versa. If I'm using DE, my perpendicular side would be DF. So therefore they're going to intersect at this corner, which is point D, and those coordinates are 1, 2. So I gave you two different examples. I gave you one that was a right angle, and then I gave you a right triangle, and one that was an acute triangle. So if you still have questions, let me know so that I can find another example in case you want to practice some more.